My name is Konrad Jakubiec. I mentioned I am the software engineer and also manager of the VirtusLab. I have been working here for almost 3 years. I'm passionate about domain-driven design, reactive microservices, and event-driven architecture. I'm also a leader of a domain-driven design guild here, and spend my free time playing down. So hopefully we may meet also on some geek or events over the Kraków of the world. My presentation is divided into a couple of parts. Firstly, I would like to highlight the overview of the basic components of Kafka. Then we will switch to what is very important to understand topics. Next section is dedicated for consumers and how they work together. Next one is about the extension, so what the Confluent platform gives us in terms of the Kafka ecosystem. Not the last but very important part is a summary, which we will just take what I've been presenting and also provide some examples. And at the end, I would love to share you some references which I found handy and helpful when it comes to the Kafka. I would be grateful if you can ask the questions after the presentation. So let's begin. The Apache Kafka was designed and first built in the app LinkedIn, and because they have a very big stream problem, so they came up with some idea how this stream can be done here. Mainly speaking, it's a distributed streaming platform which offers fault tolerancy, persistency, and horizontal scalability. And it might be the foundation for event-driven architecture. And at this point, I would like to ask you a question. How many of you have worked with Kafka, even for the pet project? Okay. And how many of you have a production experience with Kafka? Okay. So hopefully I will shed some new lights on the basics of it, and then there will be a next presentation made by Daniel with a deep dive what we can do as well with Kafka. So starting from the very basic architecture, there are a couple of components. The very main one is the Kafka broker, which is here. This is something which we are going to install and to run on any dedicated server or possibly container. But to do it, we need a zookeeper. It's a dependency without it's not possible to run Kafka at all. Zookeeper is important because it stores some broker and topics metadata, and for example, it's also responsible to choose a controller. It's kind of a leader within the Kafka broker cluster. On the left side, we have a producers who just writes records to the Kafka broker, and on the other side we have consumers, and as far as I know, currently consumers, when it comes to the partition offsets, are no longer storing this offsets within the zookeeper. So the very important thing in Kafka is topics. This is the core abstraction. It works like a commit log. And it is crucial to understand that records are stored at the end of a particular commit log, so the topic. As you can see, log can be partitioned, and it is represented by partition from 1 to 3, and it gives us the horizontal scalability. It means that to achieve the best parallelism of a processing, we can the maximum is the number of partitions for a particular topic. Also, it's worth mentioning that topics are fault tolerant because we can provide the replication factor, which means that the particular topics will be replicated to another broker, which is represented here. So we may ask where topics lives, and topics lives within the brokers. Having a cluster of, like here on the diagram, of 3 brokers, the topic A is replicated to 2 of them, the first and the second. Also, topic A has 2 partitions, 0 and 1. As you can see, whenever the producer writes a record and there is a partition calculated to which the record should be stored. It can be stored either on broker 1 or on order 2, depending on the partition value. Of course, it is possible as well to have just one partition, so the only one broker in this case will be responsible for writing. And when it comes to producers, producers do not directly store records in a topic, but send the request to store a record to the Kafka broker, and then Kafka broker decides where the record should be put, bearing in mind the current replication factor, the policy, how the partition is calculated, and so on. On the other side, there are consumers, and consumers can read data from not only one, but multiple topics at once. Speaking about the replication, very crucial thing is that there should be only one leader which is responsible for one partition within the singular topic. In this example, we have a topic A, which has, again, 2 partitions, and as you can see, the leader for partition 0 is broker 1, and for partition 1 is a broker 2. Also, as an internal mechanism, Kafka will replicate the content of particular partition to other broker to achieve fault tolerance. When it comes to the reading, it is possible to read messages only from the leader, but in case where the leader is not available and the other replicated partition, the follower, has up-to-date data, then it is possible as well to read data from it. Okay, so bearing in mind consumers, like here, we have a topic which can be given some name, as I've already mentioned, the number of partitions, and the rectangles around the commit log represent offset for particular consumers. Consumers can create and work within a consumer group. It's a logical, let's say, division how we can have multiple instances of application which represents our consumers, but all of them should work on the same topic. So it allows us to scale well in this case. Also, when it comes to the offset and committing of it, by default, it's the settings is auto commit. So it means that after the couple of milliseconds or seconds, the commit will happen. It means that it allows us to have a duplicate reads, and if we are not ready for this, we can commit it by ourselves. So just perform a manual commit. Here, there is an illustration which depicts how to achieve the highest possible level of parallelism when it comes to the consumer group. Topic 1 has 4 partitions, and the consumer group 1 also has 4 consumers. It means that each consumer will be given 1 partition to process. And it is not possible to, for example, that the partition 0 is processed by consumer 1 and then 2. Always 1 partition is assigned to exactly 1 consumer. The consumer group 2, alternatively, has only 2 consumers, the application which consumes data, and 2 of partitions are assigned to the singular consumer. It's worth to remember it whenever we design our application, how many nodes or consumers we will have within the group to achieve better scalability. And Confluent platform is like an extension, the set of components and libraries which completes Kafka ecosystems. We've already talked about some basics, but Confluent gives us some additional libraries like REST proxy, KSQL, stream, schema registry, as well as some enterprise, more operation-related things like monitoring, management, and mirroring. As well, there is a way to run Kafka on the dedicated platform. So right now, I would like to jump to the first extension, which is the Kafka Connect. Kafka Connect is a set of libraries, the data integration, which works like sources and sinks. Sinks on the left side are data sources. For example, very common pattern is to have a change record capture pattern. For example, let's say we have a MySQL or Postgres, and we can use the Debezium to just take all of our data changes into the Kafka. Then, like some insert or updates will be available in the Kafka topic. On the other side, we have a sink, for example, to S3 bucket on AWS or some REST proxy or maybe Hadoop, which will consume the records from Kafka and extract it to some external system. It's kind of handy when it comes to the integration of different parts of our architecture. The next one is a schema registry. This is the crucial thing when we are thinking about the maintenance and evolution of our schema of data and records which we put into the Kafka. It is based on the RESTful interface for storing the Apache Avro schemas, where the data is described in a JSON format. Of course, we need to think about the forward and backward compatibility, but still having a schema registry, it is possible for consumers to read the current version schema and read appropriate version when it comes to the reading messages, because the schema ID is tied to the message metadata as well. The last one, very powerful, are streams. We can think about the Kafka streams like mechanisms and methods to incorporate any kind of streaming operations like mapping, flat mapping, filtering, which are based on the Kafka topics. The basic components like a producer and consumers are hidden from within the Kafka streams libraries, and we will just focus on writing our stream processing like in a Java streams. We have a bunch of methods, the aggregation, which are possible to achieve using this library. So I think that's all when it comes to the very quickly Kafka introduction. We covered brokers, Zookeeper, which is important part to run the Kafka. We have some understanding what topic means in terms of Kafka and how it can be divided into partitions. As well, I've showed you what are the consumers, how they can work together when we have multiple instances to achieve good parallelism. And at the end, there are a bunch of extensions, not all of them, but I think that the most crucial one, the Kafka Connect, schema registry, and streams. As I mentioned, here's a bunch of references. The two of them are just links to official documentation from Confluent and Apache Kafka. The third is a very good book, the Kafka Define Guide. There are plenty of examples how we can run Kafka. They are quite nicely written. The fourth one is for more experienced and advanced usage, because it is about building whole data streaming application. And the last one is a blog post about the Kafka storage internals. It brings me to the end of my presentation, so thank you for your attention, and I would love to answer your questions. Any questions? Something wasn't clear?
What kind of messages Kafka process? Is it like huge binaries, or it should be something small?
I think that there is a limit of message, but I don't remember from my mind, but it cannot be too huge. I think that the rule of thumb is not to put too huge, like let's say, I don't know, maybe two megabytes.
By default, it's 1 megabyte.
Yeah, 1 megabyte.
By default, it's 1 megabyte. So actually, I will talk about this, about data schema, but you should try to keep the same size of messages. This is the most optimal, but they shouldn't be like very big messages. It shouldn't be over 1 megabyte. Only in some specific cases.
It wouldn't be a good idea to pass, I don't know, huge XMLs, some messages.
Mm. There is a pattern when it comes to the event-driven architecture, which is just it's called events notification. For example, you notify some external party that, well, something happened, and there is an ID of this action, and you can, even the link can be provided in this message, that here you can take a full set of changes within this notification.
What do you use Kafka for, and why did you choose it?
Okay, so here at VirtusLab we use Kafka for, it's called colleague eventing platform. So all work cycle related changes made for an employee, for example, the new joiners, leavers, movers, somebody got promoted. So all of these things are provided through the Kafka interface. And Daniel will speak about the particular use case for which is related to risk engine and analysis of a threat and so on.
But did you consider any other message queue, message broker?
We did one ourselves, but I wouldn't share it in public because it's just our internal project. I think that at the very beginning the NATS was considered, and I think also AWS Kinesis, but it costs a lot. I mean the Kinesis.